Today we are going to discuss C dynamic memory allocation. We already discussed the C static memory allocation with the help of the arrays. The main limitation of array is, suppose if you are declaring A of 100 locations in a array element, if you are used only 80 elements means that remaining 20 locations are waste of memory. Similarly, in the other situation, suppose you need 120 locations, but already you declared only 100 means that is there is no space in this situation. So in either way, it may be sometimes wasted or it may be sometimes needed. In both the situation, array is not supposed to help with this because it is a static memory and it will be declared at the beginning of the program and also the memory is allotted during the compile time itself. We cannot modify during runtime. Okay. To avoid these limitation, we will introduce dynamic memory allocation in C with the help of the library functions malloc, memory allocation, calloc, contiguous memory allocation, free allotted space is freed, then reallocation, realloc. And these functions, library functions available in stdlib.h. As like your stdio.h, we have one more header file called stdlib.h. That is standard library file. In that, these functions malloc, callalloc, realloc, free are available. So if you want to use malloc, calloc, realloc, and free means you have to include this stdlib.h in your C program. Then first one is calloc. As I said earlier, the name, malloc. First one is malloc. So as I said earlier, the malloc stands for memory allocation. It uses a block of memory specified by the number of bytes, and it returns a pointer of void. Already we discussed there are two types of pointer. One is typed pointer, another one is untyped pointer, or generic pointer, or void pointer. So here it returns the void pointer. Okay, so the syntax of malloc is ptr equal to cast type asterisk malloc size. And example is ptr equal to float asterisk malloc 100 asterisk 100 asterisk size of float. Okay, so the above statement allocates 400 bytes of memory because we will assume the float size is 4 bytes, and the pointer ptr holds the first byte in the memory location, that is the starting address of the memory location. This expression results in a null pointer if the memory cannot be allotted. Suppose if the specified memory is not available in your system means it returns null pointer to the expression. Okay. Then next one is callalloc. It is stands for contiguous memory allocation. Malloc function allots memory and leaves the memory uninitialized, whereas callalloc function allocates memory and initializes all bits to 0. That is the difference between these two. That is one of the difference. The syntax of callalloc is ptr equal to, again the same thing. Here we have to specify n value along with the size. In the example, we will specify 25 comma size of float means float size 4 means it will take 100 locations. Okay. The difference between these two. The malloc function will create a single block of memory of size specified by the user, whereas calloc function can assign multiple blocks of memory for a variable. And also malloc function contains garbage value, whereas memory block allotted by a calloc function is always initialized to 0. So these are the two differences between the malloc and calloc. Then free. The dynamically allotted memory created so far, either calloc or malloc, or even we will use realloc later. That and all freed by using the function called free. Syntax of free is free the pointer variable name. The statement frees the space allotted in the memory pointed by the PTR. You can see one example program. So this program to calculate the sum of n numbers entered by the user. Suppose I entered 3 numbers means it will display the sum of all the 3 numbers. For that we will write one program by using malloc and free. So first we declare by using integer data type ni, one pointer variable ptr, sum, and initialize the sum value as 0. Then you enter the number of elements, that we will ask the number of elements from the user. In scanf, the user types some number. It may be 3 or 5 or 10, whatever may be the number. Then in next statement, we will allot the memory of that type, uh, of that number. PTR equal to int asterisk malloc n star size of int, because we already declared all these things are integer type. So we will allot the size of integer only. If suppose memory is not allotted, as I said earlier, if PTR equal to null means the error memory not allotted, which means after executing the above statement, that is PTR equal to int asterisk malloc, this statement, if the specified memory is not allotted by the system due to insufficient memory, then this printf statement will be executed and display the same to the user. Okay. If the memory is allotted, it will not be executed. That is the point you have to remember. You already know exit of 0 is this. If it is executed, then control comes out of this program by executing this exit of 0 as like return of 0. Okay. Return 0 we will use only for main function at the end of the main function. But exit 0 we will use wherever you want as like break. Then printf enter the elements. We will ask the number of elements one by one from the user. Using on for loop, we will get the value from the user. That is incrementing the ptr plus I. Then we will sum. Star ptr plus I gives the value of the number entered by the user stored in the ptr plus I location. So the value is one by one added by using this statement. After that, we will just print the sum value here. Okay. Then we will free the PTR by using the free function. So output of this program is the user initially give 3, then enter 3 numbers 100, 20, 36. Then the sum value 156 will be displayed. Okay. Any doubt in this program? Then this is another example by using calloc and free. The same method we will use here. Only we will change the, instead of malloc we will change here the statement as calloc. Again If it is not done, we will check the null, ptr equal to null, then they display this message. If it is done means it will not be executed. Then we go for next part, that is I will ask the user to enter the numbers. Using this for loop, we will get the value from the user and add that value by using this statement. Then finally print the statement and free the ptr. Same example. Okay, any doubt in CLog? Then realloc. Suppose, as I told in the beginning, if you are allotted initially some amount of memory to the program or some module, later if you want to increase the memory, means you can increase it by using reallocation function, that is realloc. Also you can decrease the memory by using this reallocation. Both increase as well as decrease also possible by using reallocation. The general syntax is ptr equal to realloc ptr comma x. Okay, where x is the new size. Suppose we are already given some size n, you want to give the new size means you have to give it by using the x. You'll see the one example, you can understand better. So as usual, we will allot the memory by using malloc. In address of n1, we will allot the n1 size and print addresses of previous allotted memory, all the memories one by one. For printing, we are using star pc, pointer character like that. We will use star pc. Star p also you can use for printing this address values. Okay, pointer address value you can use star p or star pc you have to use. Then we will print all the addresses one by one. Then we will get the new size from the user, and that size is you can get it in n2. Then by using realloc and n2, you will allot the new size. Okay. Then we will print the new size memory values by using one for loop. Then finally free all those things. So the output, see the output. First we will give the size as 2. The addresses of the two allotted memories are printed. Then we will increase the size as 4. Then the initially allotted two sizes will be printed. After that, newly allotted size will be printed. Any doubt?